hopefully you did well on your quiz 31B just now. We've got just about 25 minutes to review for your test tomorrow. So I want to go over some things with you very quickly. I want to start by going over the memorized constructions. I've told you to be reviewing them the last few days. Let's very quickly practice them. So if you would, get your compass out. You've got some paper out there. And make any arc you want using your compass, any old arc. We want to bisect this arc. Again, when you hold your compass, you'll want to hold it down here at the base and sort of roll it in your thumb as you turn it. That way it keeps a nice, easy pressure on the point. If I wanted to bisect this arc, what would I need to do first, Quentin?
Yeah, draw a line.
But my suggestion would be draw the chord that joins the endpoints of the arc. So I'd start there, okay? Draw the chord, and then once we've got the chord, Audrey, oh, you said a certain amount. Like what certain amount? Bigger? Like this? More than half. There we go. Open it more than half. I think it could be any amount more than half, as long as it's more than half. And good. Make an arc above and below. Of course, go to the other end. And really what we're doing, Audrey, is we're making the perpendicular bisector. Now, a word of caution, remember, make sure that the perpendicular bisector doesn't just go through the line, make sure it goes through the arc. Okay, so that's the key point right there, is where it bisects the arc. It should also go through the indent in your paper. Now, if it were on the test tomorrow, obviously you wouldn't see an indent, would you? Okay, because it'd just be an arc that's printed up there on the paper. But yeah, you have that luxury of seeing the indent. You can see that it goes through. Questions on this? Go ahead and draw any line, maybe a downward line. And then pick a point. Let's call a point maybe right about here, below the line. We're going to put a parallel through that point, parallel to the line. And Chris, what would we do first? I want to make a parallel.
Open your compass a certain amount.
What certain amount?
It can go like under the line.
Okay, so go beyond the line. Okay, this is one way to do it, certainly. Real quick, before we all do this real quick, so you're thinking, make the arc through, make more arcs to make a perpendicular, and make sure that perpendicular goes long, and then do another perpendicular on the other side. That'll work. It's not the most efficient way. Now, do you remember the other way too? Now, it wouldn't be wrong on the test tomorrow, but do you remember the most efficient way?
I think so. Because that was the Mike Wazowski rule.
Yeah, Jamie, do you remember the more efficient way to do it? Start with a transversal. This transversal method is going to be the most efficient way. Remember, when you make your transversal, whatever angle you choose to make it at, I'm going to go this way with mine. You don't need the transversal to go through the line very far, but you do need some room beyond the point. Okay, so barely through the line is fine, but we do need some room beyond the point to do what? Do you remember now? Chris?
To put the point of the compass on the intersection.
Good.
And open your compass past the dot.
Not past the dot, but inside the dot. We want to go not beyond the dot.
And make an arc.
There we go. We're going to mark this angle that the transversal forms with the line. And the idea, Chris, is to copy this angle from the point. So we make the arc here, then we also go to the point, make that same arc, measure across as we copy the angle now. Because that's the premise here, right? Is parallel lines equal angles. In this case, what kind of angles are equal? Anyone?
Right.
What kind of angles are we getting here?
Acute.
They appear to be acute, but with respect to the parallels and the transversal, these angles are called class corresponding angles. Right? We're trying to get corresponding angles equal is kind of the idea here. And that's the quickest, easiest way to do it. Transversal, arc, arc, measure, measure, done. Quickest, easiest way. We also used then this method to take any line, maybe make it a few inches long, and divide it into equal segments. And for sake of time, let's just do 3 equal segments. We understand, you know, if we wanted more, we could certainly do so. What would I start with here, Ethan, if I wanted to divide a line into 3 equal segments or trisect the line? Draw another line. Just where? Coming off that first end point. Remember I told you when you make the line, make it nice and long, a nice long line. And if we're trying to trisect the line, Genesis, I'll want to then
open your compass as much as you think you can fit 3 sections.
Good. So I'm going to be able to fit 3 of these. I can easily fit 3 of these. Maybe right about here. Okay, so open your compass some reasonable amount. You can always extend the line if you have to, but I'm lazy. So I'd rather just, when I set the compass, set it so, okay, I feel pretty confident I can fit 3 of these on the line. As a strategy tip, some of you may want to put little dots right here. You may want to number them 1, 2, and 3. You may want to scribble off excess. None of these steps are essential, but they may help you to remember what to do next. Kendall, what do we do next?
Draw a line connecting the third line to the end of the line.
Good. Connect the 3 to the other end of the line. And once we've done that, we're going to make more parallels. Remember, we're going to copy some angles. So the angle in question, is it the top left, top right, or bottom angle, class? Always the angle at the bottom. That's what we're copying. So you're going to have to shrink your compass just a little bit so that you don't have it open past the 2. Right? So we need to shrink it so it's open between the 3 and the 2. Point on the 3, make an arc. Now that was when the point was on the 3. Now where do I put the point, class? On the 2. And make an arc. Now remember, the arc has to go through the line. And then I put the point on the 1. And I make an arc that goes through the line. And the reason it has to hit the line is that's going to be where my starting point on my next measurement, right? Because then I'm going to measure, okay, how big is this arc right here? And once I've got the measurement, from this starting point, measure it off. Then from this starting point, measure it off. And when we connect the dots, we will have our parallels, which will then in turn give me equal segments. And so there, and there are my 3 equal segments of the line. Questions on this construction? If you would then go ahead and make a triangle on your paper. Don't make it huge, but you know, not teeny tiny either, so that would be unfortunate. Make a triangle on your paper. We then practiced circumscribing circles. Now, word of caution. Okay? Don't get circumscribe and inscribe mixed up. Circumscribe means the circle goes where, class? On the outside. Inscribe means the circle goes on the inside. Now, if I want the circle to go around the outside, what point do I need to find? The circumcenter. Because I'm circumscribing, so I need circumcenter. Now here's the bigger question, how do I find circumcenter? Perpendicular bisectors. So, make a note of it, perpendicular bisectors for the outside. Because here's the thought, right? Listen, think of loci. I want the circle to go through 2 points. Equidistant from points, perpendicular bisector. Equidistant from points, perpendicular bisector. Equidistant from points, perpendicular bisector, right? So if you're thinking loci here, yeah, it makes sense. Perpendicular bisectors are what we're shooting for. So, now technically, you don't need all 3, right? You need at least 2, though. What?
This is for inscribed.
Circumscribed. Circumscribed. Circumcenter, perpendicular bisectors. All right? You may want to watch the video. All right. All right, so make your perpendicular bisector. I would start with the base because that's the easiest one to see. And you can rotate your paper. I can't, but you can. Remember, sometimes the circumcenter may not be inside the triangle. Remember obtuse triangles? That circumcenter ends up being outside. So don't be too terribly thrown off if your circumcenter isn't on the inside. That's okay. Doesn't have to be. Well, it just depends on the type of truck. In the center has to be, right? Because the circle's going to be inside, so the center definitely got to be inside. But since the circle's going around the outside, it's possible for the center to fall outside. And then remember, once you've found the circumcenter, point there, measure to a vertex, you've got your distance that you need for making your circle all the way around.
So you measure from the point to the what?
Well, you're trying to make it hit the vertices, right? So you put the point on the circumcenter and just measure to any one of your 3 vertices. It's going to be the same distance for all of them. So, and put the circle around the outside. This is construction 12. If you need to make a note to practice, again, you've got notes in your notebook on purpose, right? Detailed step by step, including 2 times you've done it in the notebook. So you look to those for examples. If you need to practice construction 12 tonight, do so. We don't have time to practice it again in class. You can also watch the YouTube lesson after school and practice along with the YouTube lesson if you need to. But we need to move on to construction 13, which was then to inscribe the circle. So this time you want to start with a big triangle. This time you want a bigger triangle. So it's big enough to fit a circle inside easily. Bless you. Do you feel blessed? Good. All right. Make yourself a nice big triangle this time so we can fit a circle on the inside of it. And for the inscribed circle, we need the in-center class, which means we need angle bisectors. Think of it this way. The circle is going to touch these lines, be tangent to these lines, which means it needs to be the same distance from the sides of an angle. Remember, the locus points equidistant from the sides of an angle is the angle bisector. Here's what I recommend, especially on the test tomorrow, go ahead and make all 3 angle bisectors. I would make all 3 angle bisectors, just to give you a higher degree of accuracy. And you know it has to be on the inside, because the circle's going to be inside. Technically 2 is enough. That 3rd one can act as a good check to make sure you've got them all correct. Especially for me at the chalkboard, since my point of the compass doesn't exactly poke into the chalkboard at all. The 3rd one is particularly helpful in my case. And you can see my 3 miss each other just a little bit. So I'm going to kind of split the difference and go right in the middle of all of them for my in-center. Note that I'm so close that I won't show white space between my circle and the triangle, right? But it's not as easy as just, okay, just open it up and make a circle. There's one more key thing once I found the in-center. Audrey?
You have to make the perpendicular.
Good, you need to construct a perpendicular or a distance to one of your sides. So, remember that's that Wazowski construction, as Chris referred to it earlier. And that distance is how far we're going to open our compass for our circle. And it just missed I just see just a tiny bit of chalkboard between the circle and the line. Over here, same thing, just a tiny bit. So I should have been shifted slightly over. But there we go. Questions on construction 13? Again, as needed, go back, study it in your notebook, or if you want to watch the YouTube lesson again, you can do so there. The last two constructions were a lot easier in my opinion. Constructing tangents, especially construction 14a. Really pretty easy. Go ahead and make a circle on your paper. Go and make a circle on your paper. Mark the center, I believe, on the test tomorrow. I give you the center point. Y'all haven't ticked me off too bad, so I think I'm going to go ahead and give you the center point tomorrow. And Brecken's like, what's going on? Go ahead and mark a point. Let's go at 7 o'clock. Let's put a dot at 7 o'clock. And if I want to put a tangent at 7 o'clock, Jamie, what do I need to do first?
Would you make a perfect?
Have you been studying, Jamie? Quentin, help?
Draw a line from the center to the point.
So a radius?
Yeah.
Well, halfway there. Somebody help?
All the way
Extend
through.
it.
Extend it through. Yeah, don't just draw the radius itself, but extend that radius through the point a little bit. And the reason we need to extend it, Jamie, back to you, maybe that triggered a bell for you, is I now need to construct the perpendicular at the point, right? So we just got to get the radius extended. You said perpendicular, but got to have that radius extended first. That gives you room on the outside to open your compass a little bit, make a mark. A little bit on the inside, make that same arc. And then make those crisscrossing arcs for the perpendicular. And that gives us our tangent. All right, pretty straightforward, I think, for 14a. Just remember how to start, right? That for many of the constructions, by the way, that's the first thing. It's okay, how do I start the thing? Right? How do I get started? Let's do another. The last construction that you have memorized, 14b, was starting with a circle. Again, go ahead and mark your center point. And then let's go with a point somewhere outside 3 o'clock. A point outside 3 o'clock. I want to draw from this point 2 tangents to the circle. 2 tangents to the circle. Chris, what will I do first?
Make a point outside the circle.
Well, I already did that. I picked a point outside the circle. But from that point, once that's picked, and of course on the test I would pick the point for you, what would you do first if this were on the test?
I'd make a line from that point to the center.
Good. Connect the external point to the center of the circle. All right. So kind of a radius extended, if you want to think of it that way. So they both kind of have the same idea. But we're not going to construct a perpendicular here, because that would give me a perpendicular to the circle, but not at the point. I want 2 tangents coming from the point. Now what, Kendall? Good. I need the midpoint. I think it's right about here, but wherever, I need the midpoint. So the only way to get a midpoint is to make a perpendicular bisector. I don't really care about any part of this line except the midpoint. So that midpoint's really the whole reason for that line. Otherwise, the line's worthless. I'm not going to call on Ethan, even though I really thought I was going to right now. Let's go to Genesis next, since we're just going in order here. Genesis, what do I do once I get the midpoint?
You're going to measure from the midpoint to the center.
Good. Measure from the midpoint to the center. And then, Ethan, once I've got that measurement, what do I do with it?
All the way around. Yeah, I just do the whole thing.
Good. You don't even have to do the whole thing. Though it's not wrong to, but you really are just looking for 2 parts of the arc that are going to cut the circle. Those 2 points, class, are going to be the points of tangency. So point of tangency is going to fall here and here. So all I have to do then is connect the dots. Again, going back all the way, not to that midpoint you found, to the original given point. These were the memorized constructions that you need to know for your test tomorrow. In addition to those, you have 6 fundamental loci. Now, you're going to have to be able to work with them in compound senses, right? But you need to know your fundamental loci well enough that you could draw the loci and explain in words what you drew. So in other words, make sure you really study theorems 47 to 52 and the corollary so that you can describe accurately in words. For instance, if I had some angle and I wanted to know, well, what's the locus of points equidistant from the 2 sides of the angle? Audrey, I should say the angle bisector. And then when I draw the locus, class, I always use dotted line. So I would draw a dotted line to show that locus. If I were asked for the locus of points, some given distance from some given point P, how would I describe the locus, Quentin?
A circle with P as the center, and the given distance as the radius.
Perfect. And of course, you would draw a circle with P as the center and D as the radius. Again, the locus itself would be dotted. If I had 2 points, we call one C, we call one H. How would I describe the locus of all points that are equidistant from those 2 points, Chris?
The perpendicular bisector.
Of what?
The midpoint of agency. No, agency.
Of HC, right? The line between C and H, the line that would join the points or the line drawn between the points. So we could start by drawing the line, but then with a dotted line, we would show the perpendicular bisector of the line between the points or joining the points. If I had a single line and a given distance, and I said, what is the locus of all points, that distance from that line, Jamie, how would I describe it?
It would be a parallel line on either side.
Okay, 1 parallel line on either side. So 2 parallel lines total, right? 1 on either side.
The distance given.
The given distance away. There we go. So 2 parallel lines, 1 on either side, the given distance away. And what if I just had, what if I had 2 parallel lines and I wanted all points equidistant from those parallel lines? Kendall?
A straight line that's parallel to the lines and then in this.
Perfectly said. Great job. And of course, we draw our locus just like that. Of course, if I had not parallel but intersecting lines, and I wanted to describe the locus of points equidistant from intersecting lines, Genesis?
The angle bisector.
Okay, the angle bisectors is perhaps the most succinct, but what shape or shapes will I get from my angle bisectors?
Straight line.
How many? 2 straight lines, right? The 2 straight lines that bisect the pairs of vertical angles, right? The 2 straight lines that bisect the pairs of vertical angles. And remember, for compound loci, you'd have 2 or maybe 3 of these, usually 2, that you'd have to put together, and you'd have to think of all possibilities, right? So you've had a lot of practice with that as well. That's pretty much what's going to be on the test tomorrow. Memorized constructions, unmemorized constructions, figure them out. Memorized fundamental loci, compound loci, where again you have to figure out how many different possibilities exist. And that's it. Questions at all on what to expect on the test tomorrow? Make sure you have compass and straight edge tomorrow. You're definitely going to need that. And get some rest so you can think clearly on the test tomorrow in our next lesson. All right. Any questions? All right. Well, the bell rings to be dismissed. Have a wonderful rest of your day.